In this video, we're going to take a look at some basic rules of exponents. The first thing that you need to understand is that when I'm looking at a term, that term is made up of multiple parts. I have 4, which is my coefficient. So the coefficient is the number that's in front of the term. And if there's no number listed, then that number would be 1. In this case, 4 is my coefficient. Then I have x and y, which are both bases. X and y are both bases. And the 2 and the 3 that the x and the y are raised to are exponents. For many of our rules of exponents, we need to understand primarily what a term like 4x squared y cubed really means. Well, although we don't write them, it's actually 4 times x squared times y cubed. But because 4 and x and y can't be multiplied together to make something new, we just list them all together without the multiplication symbols there. Now to take that a step further, it's actually 4 times x times x. So x squared is just x times x, and y cubed is just y times y times y. So the term 4x squared y cubed is actually the same thing as 4 times x times x times y times y times y. And we'll remember that moving forward. So let's say that we had 4x squared y cubed, and we want to take that term and multiply it by the term 3x to the 4th y. Well, if we remember what we were just talking about, this is actually 4 times x squared times y cubed. But then I'm multiplying that by 3 times x to the 4th times y. Well, multiplication can be done in any order when I have a list of things that are being multiplied. So I can take the 4 and the 3, since they're both coefficients, and multiply them together and get 12 times, and then I have the x squared and the x to the 4th, and then I have the y cubed and the y. We're over on the side here, I'm going to think the x squared is just x times x, and x to the 4th is just x times x times x times x. So thinking about it that way, wouldn't it just be simpler for me to write 12 times? Well, if I look over at this list, I actually have 6 x's, so why can't I just write x to the 6th times y to the 4th? Or in other words, 12 x to the 6th y to the 4th. So trying that again, and this time I'm going to go right to my final answer. I'm going to see that my coefficients 2 and negative 2 and positive 3 will make negative 6. X and x squared, if I think about that for a moment, it's going to give me x, but it's going to be to the 3rd power, and y to the 14th power. So that is my final answer. Now you may be thinking about that for a second and wondering, is there a shortcut that we could use for those exponents? And the answer simply is yes. When you're multiplying common bases, so when you're dealing with two variables that are common, for example the x's or the y's, when you're multiplying common bases, you simply add the exponents on those common bases. So for example, I had x and x squared. 1 plus 2 gives me that 3. And then in the other example, I had 5 and 9. 5 plus 9 gives me 14. Very similar problem, very similar idea. Might be, what if I had that expression, 4x squared y cubed, and I'm squaring the whole expression? Well, that would be the same thing as having 4x squared y cubed multiplied by 4x squared y cubed. And using the rule that we just identified, that would be 16 x to the 4th y to the 9th. So looking at that problem, students begin to wonder, is there another shortcut that can be applied when you have a base with an exponent that's raised to another exponent? And the answer again is yes. Now, I really wouldn't want to take 2x cubed y to the 6th and write 4 of them. That would just be an awful lot of work. So thinking about it, if I were to write 4 of them, how many 2's would I have? Well, I would have 4 2's. So in other words, I would have 2 to the 4th power. How many x cubes would I have? Well, I would have 4 of them as well. So I would have x to the 12th power, because I'd have 4x cubed, adding the 3 up 4 times makes 12. And then y to the 6th, again I have 4 of them, so it becomes y to the 24th. So a very simple rule here is that when you're raising powers to other powers, take the exponents that exist for every part of your term and multiply by the exponent that your entire term is being raised to. So 4 times 1, if I look at this 1 and this 4, that gives me 2 to the 4th. 3 times 4 gives me x to the 12th, and 6 times 4 gives me y to the 24th. And just simplifying that one more step, 2 times 2 is 4, times 2 is 8, times 2 is 16, x to the 12th, y to the 24th.